All right, guys, we're going to do an example of a problem where you are given a term that represents three terms of a sequence or three expressions that represent terms of a sequence, but you don't know the actual values of those terms yet. So we have an example here that says the first three terms in a geometric sequence are represented by the terms negative 4x minus 1.5. So this is the first term. And I'm just going to write that as, let's call it A1. And then we have a second term, which is represented by 3x, and a third term, which is represented by negative 2x. All right, so we don't know the values. If we knew x, we would know what those terms are. A very important part of this here is that it's geometric, so that's key. We know it's a geometric sequence. So as an example of a real-world problem that we can draw from, let's say that I have this geometric sequence. All right, so those are three terms where one term is being multiplied by some constant ratio to get to the next term. And in this case, it would be times negative 3 times negative 3 and so on, and that would continue, right? Well, I could build an equation over here that would be true that would say that negative 9 divided by 3 is the same as 27 divided by negative 9. And this should be true, right? Because if I'm multiplying by negative 3 to go from term 1 to term 2, then term 2 divided by term 1 should be that common ratio. And if I do the same thing to go from term 2 to term 3, then if I divide term 2 or term 3 by term 2, I should get that common ratio again. So negative 9 divided by 3 is negative 3, and 27 divided by negative 9 is also negative 3. These two things are equal. And we're going to finish dealing with this right now. We're just going to leave it there. So let's take that over to this example where we have term 1, term 2, and term 3. I know that the relationship between these terms is that we are multiplying by some common ratio r. Just don't really know what it is yet. But that's okay, because I know that if I take the second term and divide it by this term, that will give me r. So if I take 3x and divide it by negative 4x minus 1.5, that equals r. And I also know that I can get r by taking this term and dividing it by this term. So if I do negative 2x over 3x, that will also equal r. So I can set those two things equal to each other and solve this equation to find out what x is. So now we're just going to go through the process of solving for x here. One thing that I would do really quickly is cancel these x's because x divided by x is just 1. And then the next thing that I would probably do would be to multiply both sides by 3. So I'll do that next. Now I have 9x over negative 4x minus 1.5 equals negative 2. All right. And then I'm probably going to multiply by the denominator here to get that denominator to cancel. Got to do it on this side too, though. Okay, so I'm going to distribute that right-hand side equals 8x plus 3. Now, some of you might be wondering, why didn't I just cross-multiply? Well, I could have, at this point, cross-multiplied. I don't like to use the term cross-multiplication. It's a little bit confusing. So if you had cross-multiplied, you would go straight to there. All right, but I'm going to avoid that and just multiply by each of my denominators to show that that's what cross multiplication really is here. Now I'm trying to solve for x, so I'll just subtract 8x minus 8x, and now I have x equals 3. Great. That's very useful because now I can take this and actually write in what the values of those three terms are. So instead of having 4x minus 1.5, I can just plug in that 3, put a 3 right there, and evaluate that and get negative 13.5. And I can do the same thing here, put in a 3 there and a 3 there, and get my terms 2 and 3. Now, let's pretend almost that this problem started here and said determine the value of the sixth term in the sequence? Well, I'm going to figure out what my common ratio is because they told me it's geometric. And anytime I want to figure out what that ratio is, just like we just saw, I can just take two of my terms and divide them. So if I want to figure out what that ratio is, I could just take my -6 and divide it by my 9, -2/3. So that must be my common ratio, times -2/3 times -2/3. And we can check that, right? I could do it this way too. I could do 9 divided by -13.5. If you use a calculator and ask it to turn it into a fraction, it's going to give you -2/3. Okay? So I'm setting up an explicit formula for a geometric sequence. I'm going to call it A sub n. I need my first term. I need my common ratio to the exponent, which is n minus 1. And now all I have to do, if I'm finding the sixth term, is just find A sub 6, which is going to be -13.5 times -2/3 to the 6 minus 1 power. And I'm going to evaluate that in the calculator, just show you that the next step here is going to be -2/3 to the 5th times -3.5. And with the calculator, you should evaluate that, turn it into a fraction, do not leave it as a decimal, and you'll get 16/9. So the sixth term of that sequence is 16/9. It is a long process. It's a long process because you need to figure out what x is first, and then you're going to use x to figure out what these three terms actually are because they're given in very cryptic expressions, not in terms of the value of the functions. But the key here is that that it's enough to just say that it's geometric. That's your clue that the relationship between these terms is multiplication by some common ratio. Now, I'm not going to do another problem like this right now, but let's just say that instead of that saying geometric, it said arithmetic. If that said arithmetic, then immediately this is not times r anymore. This is plus, because it's arithmetic, some common difference. All right, that would change everything because from there, we wouldn't be dividing our terms, we would be subtracting them. 3x minus -4x minus 1.5 equals -2x minus 3x. And then we would solve for x that way. So if it's arithmetic, we're going to want to use subtraction because we're talking about a difference between two terms. And if it's geometric, we're going to use division because we're talking about multiplication between two terms, all right? So hopefully that's a good enough example to help you guys with problems like this.